Solutions units. This is the second video, and we are looking at, in this section, separating out mixtures. So we talked about at the beginning of the unit that we have matter, and matter breaks up into pure substances and mixtures. And then we said that there's two different categories of mixtures. You have homogeneous mixtures and you have heterogeneous mixtures. But the thing with mixtures is you can always separate them through a physical means. Meaning that things aren't chemically combining together, that you don't have to go through a chemical reaction to break them apart like you would with a compound. So the different separation techniques that we see in chemistry, there are 6 very common ones that you would need to know how to recognize. We do these quite frequently in a chemistry lab. There's some of them that are more frequent than others, but we're going to go through how to separate each of the different methods in a chemistry course. So when we're looking at our different separation techniques, we have these different ways, and I'm actually going to show you some pictures and things like that. One of them has a video because we don't actually have a setup like this in the chemistry lab at Crosby High School. But we have filtration. That's the most common way that we use separating mixtures in the chemistry lab. We have distillation. We have crystallization, which we'll do in a few more labs than this year. We have decantation, which we've done in 2 labs so far, where we pour off liquids and it leaves a solid behind. We have physical separation, which is using your hands or using a tweezer or using a magnet to separate out magnetic matter, things like that. And then we have chromatography, which is separating things based off of color. And you should have done this in biology. However, I believe you probably didn't last year because I don't think that we were actually on campus when you did this part of the year for biology. So filtration is the first method for separating out different mixtures in chemistry. And this is where you have a solid chunk that's big enough that it's not going to pass through the filter. So this is typically what it's going to look like here, where you have a filter paper in a funnel. And with that filter paper in the funnel, you have a mixture of like a solid and a liquid in the test tube here. You pour it in. The solid chunk gets stuck in the filter itself. The liquid passes all the way through. This is what happens when you make coffee, or if you have a fish tank filter. The little coffee grounds stay in the basket part in the coffee filter, and the liquid passes all the way through. It pulls little bitty teeny tiny particles of coffee, dissolves it into the water, which makes the actual coffee part, but the big chunks of coffee grounds stay behind. So that's filtration. Same thing with, like I said, a fish tank. If you have the little fish that are swimming around, they go poop, it goes into the filter, the poop gets stuck in the filter, the water passes through. So filtration is very common in chemistry. Like I said, this is typically what the setup's going to look like, but you have a solid chunk, the liquid passes through the filter. Distillation, this next one, I'm actually going to show you a video of it, but with distillation here, you have 2 liquids that have 2 different boiling points. And with those 2 liquids with the 2 different boiling points, they have 2 different temperatures that you can raise them to. So if one of them has a boiling point of 60 degrees Celsius and one of them has a boiling point of 100 degrees Celsius, if you raise something to 61 degrees Celsius, the one is going to turn into a gas, and it's going to go through this setup here where it's going to cool here after it heats up, turns into a gas. This is stoppered. It's going to be forced through here. This is a condensing tube, and your condensing tube turns it back into a liquid, and it drips out the other side. The other liquid that was here that had the higher boiling point is left behind because it never reached that boiling point. So you're separating it based off of its boiling point. And again, I've got a video that we're going to watch.
Our topic for today is simple distillation.
I'm going to move it forward just a little bit.
need to remove this nail polish.
I'm going to move it forward again, just a little bit.
Nail polish can be removed by acetone. Acetone can be obtained by simple distillation.
The process of heating a liquid mixture to form vapor and then cooling that vapor to get the liquid is called simple distillation. Distillation is used to purify a liquid by separating the components of a liquid mixture. Let us perform an activity to understand simple distillation. Take a mixture of acetone and water in a distillation flask. Put a thermometer in it. Connect the flask to a water condenser. The condenser has cold water running through its jacket to keep the temperature cool. Keep a beaker at the outlet of the condenser. Heat the mixture, keeping an eye on the thermometer. When the temperature hits 56 degrees Celsius, acetone starts to vaporize. These vapors condense in the water condenser. The condensed acetone gets collected in the beaker. When all the acetone vaporizes, water is left in the flask. Acetone is collected in the beaker. In this way, acetone and water get separated by simple distillation.
Okay, I'm going to stop the video right there. If you wanted to watch the whole thing on how he cleans his glasses later on, you can definitely go back and watch that when you go back to the notes themselves. But for the sake of time, we're just going to, like I said, stop there just so you could see the actual process. So the big thing with distillation is you have two liquids that are mixed together. They have two different boiling points, and when you separate them, you have two liquids in the end. Now looking at the next type, this is where you're going to have a solid that's dissolved into a liquid. With your crystallization, your solid dissolved into a liquid, this is like sugar dissolved into water. If you have sugar dissolved into water, you let the particles of the sugar stay behind because the water evaporates away. So it's going to leave a crystal. We're actually going to do this in class with the crystal lab. But this one, I'm not quite sure. That kind of looks like sodium acetate, but I'm not 100% sure what those crystals are. But you have a solid dissolved into a liquid. When the liquid evaporates away, the solid is going to be left behind and it makes that crystal. Now the next type is called decantation. When you decant a liquid, you have an undissolved solid in the bottom, like sand in the bottom of water. And if you have sand or rocks in the bottom of water, you can just pour the liquid off and it leaves the solid chunk behind. So you're just using that undissolved solid where crystallization it was dissolved. This is not dissolved, so it's still in the bottom of the beaker, in the bottom of the glass, or in the bottom of the bucket, or whatever it is, and you just pour the liquid from one container to another. The second to last one is physical separation. So if you have a mixture of Skittles, you're using your fingers and you're picking it up and you're saying, I'm going to eat all of the purple ones first. And so you segregate all the purple ones into one pile. And then you say, I don't like the green ones. So you pick all the green ones out and you throw them away. Then you eat the orange ones. So then you pick them all out and you just eat the orange ones. So you're just using your fingers to separate them. Using a magnet works in the same way, where if you have like iron filings in a mixture itself, you would just take the magnet, run it through there, the iron would actually stick. They use that method in like a recycling facility where the metals are going through the recycling facility. They use a big magnet to get the magnetic stuff away first, and then they start to look at the different metals from there. And then the last one that you might have looked at in biology, but I don't think you actually got there in the lab itself, you have chromatography. And with your chromatography lab, you are looking at the different type of chlorophylls. And with the different types of chlorophylls here, usually you take a spinach leaf and you squish it onto a piece of paper. And when you squish it onto a piece of paper, you take that paper and put it down inside of a vial, and you put it into a separation liquid. Usually it's called hexanes, and it pulls the different types of chlorophyll to different levels, as you can see here, because they have different masses. So the heavier ones stay at the bottom, the lightest ones go way up here to the top, and then based off of the color you can actually identify the different types of chlorophylls that are in the spinach leaf themselves. You can also use this in class. If you were here, we would use a different marker or a different pen ink, and we would separate the inks based off of their colors that are mixed together. For example, a black shirt is not typically black. Black dye is almost impossible to make, so it's typically a very deep purple, very deep green, very deep blue. So when you make a mark with like a black marker, it's going to separate out into all these different colors, and you can see the different tones that are there. Brown is another one that's a big mixture of a bunch of different colors. It's typically not one pure color. So chromatography separates things on a piece of paper based off of their masses. So you have to use some type of a solvent to actually break those apart. You would have done this in like kindergarten when you made you took a coffee filter and you colored on it with marker, and then you sprayed it with water and you make a little butterfly or you make a little flower. That's all chromatography. So that is the last of the different separation techniques. On the test or on a quiz or on an assignment, you're going to be given a situation and you're going to have to identify what's the easiest way to separate out those different mixtures. Now there's one more little topic that we're going to talk about today, and that is a homogeneous mixture actually has a different name. The different name is actually called a solution. So typically in chemistry we call it a solution. We don't typically say homogeneous mixture because chemistry is a lot of solutions, which is why we have a whole unit on it. So again, some examples of solutions. You can have solutions that are gases, you can have solutions that are liquids, and you can have solutions that are solids. Any of those different states of matter. So sterling silver, like a piece of jewelry, is going to be a solid solution. Those solid solutions actually have a special name to them that we're going to find out later on in the unit, but that special name is called an alloy. Salt water, Kool-Aid, both of those are considered to be liquid solutions. Smog or air is a gaseous solution. 14 karat gold is again a metal solution. It's called an alloy. So you have different types of solutions, solids, liquids, and gases, but they are all homogeneous mixtures. In order to be considered a homogeneous mixture or to be considered a solution, you have to have all three of these properties. For your three properties of all solutions, is the fact that the particles that are there have to be very, very, very tiny. And when I say very, very, very tiny, they get broken up into their molecular level to the point that sometimes if you have an ionic compound, they break apart. So if you have water and salt, like you see in this picture here, this salt particle gets dropped into water. Water is actually polar, so it breaks it apart, and you're going to have sodium ions and you're going to have chlorine ions, sodium and chlorine, running around in the solution. When they hit each other, they're going to go back together, and then they're going to get pried apart again, and they're going to go back together, and they're going to pry apart. That's why they conduct electricity, is because you have positive charges and you have negative charges running around in the solution. So when I say that they break down very, very, very small, it is very, very, very small, down to the molecular level. They break down into ions if possible. The second thing is those particles have to be evenly distributed. So when they're sitting, they don't settle to the bottom. They have to be the same top and bottom, so the particles aren't heavy enough that the gravity is actually going to pull them down. So because they have very tiny particles, they're going to evenly distribute all throughout the solution. And when it's sitting, they're not just going to settle to the bottom. That means that gravity is actually big enough, or they're big enough that gravity is going to take hold and they're going to move them down. So you have to have all three of these properties in order to be considered a solution. Very tiny particles, they're going to be evenly distributed, and when they sit, they're not going to settle to the bottom. So that's actually all of the notes for today. If you guys have any questions, make sure that you ask. Otherwise, have a great day.